I'm getting up progressively a bit earlier each day so that I can actually finish the board, 4 sessions, in daylight, so that one, the quality of, the readability of the board is better, and 2, I don't have to subject my eyes to this damn lighting, which is still not fixed. It's been repaired by me ad hoc, but not properly remodeled. Okay. What are the themes of this board? Well, we'll finish off the showing that a multi-tape, a K-tape Turing machine is equivalent to a single tape Turing machine. That the two have equal power; they're equivalent in that sense. Then we'll do a couple of corollaries, and then I guess the theme for most of the board is non-deterministic Turing machines, and I'll explain a bit about that. The notion of non-determinism in the context of Turing machines is a bit different from what we were used to with the previous 2 machine models, the finite automaton and the PDA push-down automata, the stack-based machine. Although it's fairly familiar, there's just a few changes. And then we prove that a non-deterministic Turing machine is equivalent to a deterministic Turing machine, and that's a throwback. In fact, it's sort of interesting. We've done now 3 essential models, right, of automata. There's the finite automata, the FA, the PDA, and the Turing machine. Now, you may remember for the finite automata, we showed that a DFA, a deterministic finite automaton, was equal in power, was equivalent to an NFA, a non-deterministic finite automaton. So in those cases, those 2, for the finite automata, the deterministic form and the non-deterministic form are equivalent, they have the same power. Now, interestingly, the second one, the PDA, push-down automata, the automaton with a stack, its non-deterministic form is not equivalent to the deterministic form. It has more power. Now, no proof was given in the text, it was just asserted. Okay, so that's all we can say. Now, in the third case, with Turing machines, the non-deterministic form of the Turing machine is equivalent. It has the same power as the deterministic form. So I'll be talking about DTMs, that's me, it's not Sipser, deterministic Turing machines, and NTMs, non-deterministic Turing machines. So DTMs and NTMs have the same power. So the first and third cases, they're equivalent, and the middle, the second case, not equivalent, which is interesting. But I'm guessing you'll have to wait to high-level texts to prove that the non-deterministic PDA and the deterministic PDA are not equivalent. Right, another general comment. When we get into some of the proofs, especially the if and only if type proofs, I felt rather irked. I'm learning. I have a sort of ambivalence towards Sipser. I like his overall structure. I can see why the text is very popular, pretty well the Bible nowadays, because it is well structured. But the mathematician in me feels irked at one. Sometimes he's just sloppy. He's not. He could be a lot clearer, and he's not a mathematician. I assume, because he doesn't conform to the usual pure mathematical conventions, and those conventions exist for good reason. They've been developed, they've evolved for good reason. For example, myself, when in two cases there'd be two proofs, or actually two corollaries, and of the if and only if form. And I was getting annoyed. I was looking at his reasoning and asking, now which way is he going? This particular, these few sentences, is that the if part or is it the only if part? And it's precisely to avoid that kind of confusion and frustration that the pure mathematicians have set up quite a strong convention that you begin with the if part. So if you have two mathematical statements, P, if and only if Q, then you begin with the if part. So in other words, P if Q, which you translate into if then form as if Q then P, which is from right to left. That's the first part. And then the second part is the only if part. So that would be P only if Q, and that translates into if then form as P if P then Q, or P arrow Q. Okay, so I use that convention because I like last night, yesterday evening, for my own benefit and working ahead, like a decade or more. I was looking through some PhD 2-level math physics texts on quantum gravity and stuff like that. And it's clear there's been a real merge between the pure mathematicians and these advanced mathematical physicists. They just mingle. They talk the same language and so forth. So, and that's one of my longer term goals. I mean, these courses, they're just preliminary. They're just beginning, right? These undergrad courses, well, senior master, first year master level courses, they're just preparatory for the real effort to come later. And looking at this merge between the mathematical physicists and the pure mathematicians, they're talking the same language, they have the same conventions, and so I'd like to train you into the same way of thinking, to make you mathematical physicists, or rather pure mathematical physicists, so you're both. And so you need to be become familiar with that manner of thinking. And Sipser's way of doing things is not along that line. So I've rewritten the proofs of the corollaries in the pure mathematician's way. One, I think it's clearer. I find his reasoning, it's probably valid, but it's woolly. You have to scratch your head. So it's clearer. And two, it's in the mathematician's style, and hence four graduate levels higher than this one. It will be consistent with the style that I'll be teaching, that you'll be reading if you're reading these books, these research papers at that level, at PhD 2 level. It's the same style, so I'm motivated to get you thinking along that same style from the beginning. Why learn bad habits, right? So now that's casting aspersions a bit on Sipser, and valid. Like I say, I'm a bit ambivalent about certain aspects of his text. I assume he's not a mathematician. All right. So let's get to the nitty gritty. What are we doing now? I think we're talking about. I think we're in the proof stage. Let me just check. Are we in the proof idea or the proof stage of showing that a single? Are we in the proof idea or the actual proof?